We see a lot of dinosaurs in popular culture, and a lot of that can be attributed to Jurassic Park and its success. We get dinosaur books for kids, dinosaur-themed birthday parties, dinosaur movies, dinosaur video games, the list goes on. But what a lot of people don't understand is that not every reptile-looking animal from prehistoric times is a dinosaur. And I know what most people are going to say. It's not a big deal. Why is it so important? Well, for most people, it probably doesn't matter. But it matters to me and literally anyone who cares about paleontology, and it definitely matters to scientists. For example, the new Jurassic World Rebirth I thought was a pretty good movie. However, we gotta talk about the three main dinosaurs that the team is trying to get blood samples from. First off, Mosasaurus, not a dinosaur, but a marine reptile. They're pretty closely related to monitor lizards and snakes. They're squamates and part of a more specific clade called Toxicophora. Therefore, Mosasaurus is not very closely related to dinosaurs. Next, we have Quetzalcoatlus. A giant flying dinosaur? Nope. It was giant, about the height of a giraffe, had a 35-foot wingspan, but was not part of the dinosaur family. It belonged to a clade called Pterosauria. Pterosaurs split off the evolutionary tree far before dinosaurs, with their most recent common ancestor being Ornithodira. Ornithodira is characterized by their cervicals being distinct from their dorsals, elongate tibia and metatarsals, and the loss of bony armor. You might think of pterodactyl, but the scientific name for that animal is Pterodactylus, which was the first pterosaur to be described. Lots of people will call any pterosaur pterodactyl, when in reality, Pteranodon is a more accurate representation of what animal they're thinking of. So Quetzalcoatlus is a pterosaur, and it's specifically in the Asdarchidae family, which includes a massive group of pterosaurs such as Hatzicopteryx. Finally, the last dinosaur is the Titanosaurus. This scene in the theaters literally made me tear up, and it was so good. But the problem here is that Titanosaurus isn't a valid genus. There is a group called Titanosauria. Titanosaurus, however, was ruled invalid as fragmentary remains couldn't distinguish it from others in the group. So, in the movie, Titanosaurus is really just a mix of different dinosaurs into one, so it definitely takes creative inspiration, and it makes a very beautiful looking dinosaur. I had to get that out, but onto the more important stuff. How does one classify what is and what isn't a dinosaur? There isn't really a straightforward answer, but one way to do it is to look at anatomical features of the question animal and decide what similarities it shares with a possible relative, what makes it different. You can pay attention to special things like posture, the number of digits on its hands and feet, teeth, and the shape and orientation of bones. But let's get into some specific things that are a must for it to be a dinosaur. First, there's a pretty important distinction between how dinosaurs walked and the other reptiles at the time, and it plays a big part in their rise to dominance. Reptiles such as turtles, lizards, and crocodiles are what we call sprawlers, where their arms and legs are to their side and their back bends side to side when they walk. Because of this posture, their bellies are close to the ground, and they can only scuttle short distances quickly before having to take a break. Contrary to this, dinosaurs have erect or upright posture. Their arms and legs are directly underneath their body, and it allows them to use their whole limb, limiting lateral movement and allowing more vertical movement of the limb and enhancing forward movement. The importance of this is that it allows for long distance travel, unlike the other reptiles in their environment. Having an upright posture doesn't make you a dinosaur, but identifying something with similar anatomical features as another dinosaur, as we will learn soon, can be important in determining what kind of animal you're looking at. It's not all-inclusive, so you have to make sure you can't jump to conclusions too quickly. More traditionally, let's look at binomial nomenclature. Dinosaurs belong to domain Eukarya, kingdom Animalia, phylum Chordata, subphylum Vertebrata, class Dinosauria, order Saurischia, or Ornithischia, and so on and so forth depending on the dinosaur. There are more specifics, so let's try as an example. We're going to use my favorite dinosaur, Carnotaurus sastri. So, domain Eukarya, kingdom Animalia, phylum Chordata, subphylum Vertebrata, class Dinosauria, but now this is where it changes. Order Saurischia, suborder Theropoda, infraorder Ceratosauria, family Abelisauridae, genus Carnotaurus, species Sastri. Next, we'll go over a quick history lesson. So the term dinosaur was coined by Sir Richard Owens in 1842, and this translates to terrible lizard. A couple decades later, British paleontologist Harry Shealy proposed two orders in Dinosauria, specifically based on the structure of their hips. So Saurischia is described by their lizard-hipped style, and Ornithischia is described by their bird-hipped style. So dinosaurs have three main bones in the hip. We have the ilium, the ischium, and the pubis. They also have an opening where the femur attaches to the hips, and this is known as the acetobellum. So the lizard-hip saurischians are characterized by their pubis and ischium far apart and facing different directions. The pubis extends posteriorly and the ischium faces anteriorly. The bird-hipped ornithischians are characterized by their pubis and their ischium close together, both pointing posteriorly. In this video, I'm just going to go over Saurischia because it would take way too long to do everything. So let's start with Saurischians. They are divided into two major groups. We have theropods and sauropods. Keep in mind that this list I'm about to go over is not exhaustive, and I just want to go over some important distinctions. So theropods are generally the group that receives the most attention because these are the meat eaters, mostly, big and scary, like T-Rex. The grand majority of them are meat eaters, but some theropods like Therizinosaurus and Dinosaur are believed to have been omnivorous or even herbivores. An extremely important trait of theropods and other dinosaurs are its hollow bones. These allow them to be lightweight, more agile, with more efficient breathing. Air sacs through their body enhance this efficient breathing, and it has a unidirectional airflow, which is seen in bird lungs today. This is just one piece that connects birds most closely to theropods. Further, theropods usually have three-toed feet with sharp claws, and you can see these on dinosaur footprints and trackways. Subdivisions within Theropoda are very diverse. We have clades such as Ceratosauria, which includes most famously the Ceratosaurus from the Jurassic, but also in the Cretaceous we have abelisaurs like Carnotaurus, as I mentioned earlier. There is a sister clade, Titanorae, which includes allosaurs, megalosaurs, spinosaurs, just to name a few. Another clade is Coelurosauria, which is the most popular group for multiple reasons. We have the evolution of feathers, we have T-Rex and other popular dinosaurs, and just how diverse this group really was. So soft tissue is normally very hard to preserve in fossils, but there is some evidence of these dinosaurs that had feathers, and they're mostly cool-like feathers, also known as protofeathers. So Eutyrannus was an early relative of T-Rex. So it was a tyrannosaur that had evidence of feathers, and this complicated the debate on how many tyrannosaurs had feathers. Most recent research points to the idea that, mostly scaly, T-Rex might have had protofeathers behind its head, but there's no evidence of that, so we're not going to get into that too much. But a quick side note, since we're in this area, it's November 2025, and last week Nanotyrannus became valid, ending the debate over the juvenile T-Rex specimens, and two new specimens came out of it, so shout out Nanotyrannus. Within Coelurosauria, we have a group that includes Compsognathus and relatives, aka the little green guys from Jurassic Park, that absolutely jump some random side character somewhere in the movies. And also similar to them, we have Ornithomimosaurs. They're very similar to ostriches, and they had a toothless beak, meaning they were probably herbivores. Dinosaurus is here, which was a 35-foot-long, duck-looking dinosaur that had the bill. They also had 8-foot-long arms, so if you ever go to the American Museum of Natural History in New York, look for the Terrible Arms exhibit for some perspective on that. Next, Maniraptorans. Interestingly, they first evolved the wishbone and have become more bird-like in recent interpretations. Some dinosaurs include Alvarezsaurus, Therizinosaurus, who had over 3-foot-long claws for scooping vegetation, and oviraptors. Within this group is paraves, so we can see we're getting a little closer to birds. So paraves, the most important group I'll focus on within here is dromaeosaurs, or the raptors. They are identified by their second digit on their toe having a sickle claw that was held above the ground. It is thought that this was used to hold prey down while biting and killing, or maybe even used to slice and disembowel prey. Most famous of the dromaeosaurs is the velociraptor, which lived in Cretaceous Mongolia. It's famously known for its incorrect portrayal in Jurassic Park. So Michael Crichton wrote Jurassic Park, and he based his version of Velociraptor off another raptor, Deinonychus. It was larger, and it's more similar to its real-life size. He took the name Velociraptor and made that the antagonist, as it just sounded cooler. But today we know that the Jurassic Park Velociraptor is not the real Velociraptor, and it's not even most similar to Deinonychus. It's actually more similar to Utahraptor, which was the largest dromaeosaur that lived in Utah. Also, a fun fact, Utahraptor was described just days after Jurassic Park released in the theaters. So the next group is Avialae, which is more closely related to birds than Deinonychosaurs, which is a subgroup in Paravaes. So we're at the beginning of true birds here, depending on exactly who you ask, and we start to see powered flight begin to evolve. So an early member of this group is the famous Archaeopteryx, which lived roughly 150 million years ago in the Jurassic, and whose famous fossil contained feathers. So this dino bird is the connection that links birds to dinosaurs and is very important in evolutionary terms. The group Avialae became more diverse in the Cretaceous and eventually led to Neornithes, which is generally speaking a clade that includes all modern birds. So those are the most important theropod groups. So we can get next into sauropods, who may not be as popular as theropods, but they're definitely one of the most mind-blowing feats of evolution and physics. Most obviously, these grew to become the largest animals to ever step foot on Earth, but they weren't always huge. They started off relatively small in the Triassic, and there's a term to describe early sauropods that did not walk on all fours yet, as they would evolve later. That term is sauropodomorph, which includes the early ancestors of sauropods and true sauropods. True sauropods walked on all fours, making them quadrupedal. Anyways, these sauropodomorphs were bipedal and likely omnivorous, as fossil evidence has shown sharp claws that imply either tearing flesh or vegetation. A Triassic sauropodomorph that is well known is Plateosaurus, which was a bipedal dinosaur with blunt teeth, an elongated neck to reach into the trees, and it picked vegetation that other animals were not capable of reaching yet. There's a little corner at the Museum of Natural History in New York with Plateosaurus casts and remains that were pretty cool to see in person for some size perspective. Somewhere along the line, we have the transition to true sauropods. We don't know exactly which dinosaur was responsible for this, but evidence from other sauropodomorphs imply the change happened in the late Jurassic or sometime in the early Jurassic. What we do know is that they started getting really big, and as a result they got very heavy. With this heavy weight, quadrupedal stance became more effective and necessary for these giants. Its limbs became more robust and less reliance and less use of its claws as opposed to its ancestors. A little fun fact, sauropods do not have teeth built for grinding and chewing food as we would expect an herbivore to have. They had needle-like teeth and instead relied on swallowing gastroliths, which are small rocks that would do the grinding for them in their stomach to help digest that tough plant material. So generally, sauropods split into two major groups, including Diplodocida and Macronaria. Regardless, true sauropods have a front toe claw, which is a vestigial feature from their bipedal ancestors. Starting with the Diplodocids, the simplest way to identify them is the way they are built. They commonly have extremely long tails that can get almost whip-like. They are known for having a long body plan, and dinosaurs include Diplodocus, Apatosaurus, and Brontosaurus. The latter two for a while were thought to be the same and only regarded as Apatosaurus, until Brontosaurus was found to be distinct enough to be its own valid genus. Dicraeosaurs are another subdivision within Diplodica, and are characterized by their spiny necks, like the Amargasaurus. The next group is Macronaria, who are identified most easily by their verticality or upright shape. Brachiosaurus is the best example, which is the first dinosaur we actually see in the original Jurassic Park. With Macronaria, a group named the Titanosaurs include the largest animals to ever walk the earth. Some notable dinosaurs that are titanosaurs include Argentinosaurus, Sauroposeidon, and Patagotitan. Argentinosaurus is regarded as possibly the largest known dinosaur, based on estimates from its leg and spine. Using its femur, scientists are able to estimate the size of the animal with very little other evidence. At the top levels of the measurement, Argentinosaurus could have reached lengths of 130 feet and weighed 100 tons. Sauroposeidon and Patagotitan could potentially be larger, but we only have incomplete remains that make its estimates less valid. I mentioned at the beginning of the video that the new Jurassic World had Titanosaurus, which was not a real dinosaur. While that is true, the reality is that the original fragments that were used to describe the genus were simply not distinguishable enough from other titanosaurs. It was described in the late 1800s, and it's not a scientifically valid dinosaur. However, it is important as it was the first dinosaur in titanosaurs, the group of massive dinosaurs. Things could change in the future, as paleontology is always changing and becoming more correct slowly but surely. That was a lot about Sauriskia, including theropods and sauropods. In the next video, I'll go over Ornithischia in detail just as this one. Thank you for watching, and until next time.